Ever feel like you're trying to sip from a fire hose of information? Especially when it comes to keeping up with the latest in tech.
Oh, absolutely. You're definitely not alone there.
Yeah, staying truly informed today can feel, well, more overwhelming than enlightening sometimes.
Mm-hmm.
And that's precisely why we created the deep dive. We take the sources you find, important articles, studies, maybe even those late-night research dives,
Right.
and we try to pull out the key insights, the stuff that actually matters for understanding what's really going on.
Exactly. And for you, the learner, that's the whole point, isn't it? You're curious. You want to get to the core of complex topics, but efficiently.
You need that shortcut.
We're here to provide that shortcut, less endless scrolling, more focused knowledge, hopefully.
So today we're diving deep into the recent evolution of a leading cloud data platform. You share some really interesting blog posts highlighting its newest capabilities.
Yeah, some good stuff in there.
Our mission: let's try to unpack the major advancements. Things like its fundamental features, how well it connects with other data systems, how it handles all kinds of data, structured, unstructured, you name it.
And the AI and ML integrations, too. Big topic.
Exactly. And we'll try to do this by focusing on the core concepts, without getting lost in, say, vendor comparisons, or maybe getting too bogged down in specific product jargon right off the bat.
Sounds like a plan. Where should we start?
Okay, let's get started exploring what's new.
Let's maybe begin with the foundational aspects, the core of a modern cloud data platform.
Good idea.
What the sources you provide or rightly point out is that it's really not just about processing speed or, those speeds and feeds in isolation anymore.
Right, there's more to it.
A truly valuable platform needs to offer a comprehensive solution. This means looking at how well it fits your specific needs, how seamlessly it integrates with your existing tools, the overall cost effectiveness.
And the big ones: security, governance, reliability.
Exactly. It's about the total value proposition, the whole picture.
Right, the complete picture. And, speaking of those less glamorous but absolutely critical elements, security and governance come up a lot in the material.
As they should.
A really significant point is the focus on data encryption right from the moment data enters the cloud environment. We're talking encryption being on by default.
Mm-hmm. Yeah, both when data is sitting in storage at rest and when it's being transferred in transit.
It's kind of like your data having its own built-in security detail, always on guard.
And that protection goes further. Many organizations need or want to maintain control over their own encryption keys.
Bring your own key, that kind of thing.
Precisely. And this capability offers a substantial security advantage. If a serious threat pops up, you have the ability to instantly revoke the key, making the data completely useless to anyone unauthorized.
That's a powerful safeguard. Puts you in control.
It really does.
Okay. Then we get into things like network and login policies. This is all about, building digital walls and carefully managing who can even get near the platform.
Right. Access control.
The sources highlight restricting access based on approved IP addresses and also virtual private cloud networks, VPCs.
Yeah, so if your organization channels all its online activity through a VPN or maybe a proxy server, you can essentially lock down access to only those trusted connections.
It's like having a very specific, pre-approved guest list for your data.
And the level of control is really quite precise. You can specify not just who gets in, but how they can interact.
How so?
Well, for example, you might allow your data analysts to use the platform's visual interface, the UI, for their work, but maybe prevent them from using programmatic access like Python scripts or ODBC connections.
Okay. So different permissions for different types of access.
Exactly. That kind of granular control really minimizes potential weak points.
Makes sense. Another important security measure mentioned is private networking options.
Yeah. Private endpoints, things like that.
So instead of your data traffic potentially zipping across the public internet, you can set up private dedicated connections.
Which ensures that communication between, say, your own internal cloud environments and the data platform stays isolated and secure. Like a private tunnel just for your data, as you said.
Exactly. Good analogy.
And we shouldn't forget the basics of user authentication either. The material really stresses things like single sign-on, SSO.
Right. Log in once, access multiple things. Convenient and secure usually.
It is. But for situations where SSO maybe isn't practical, strong password requirements combined with multi-factor authentication, MFA, are presented as just essential security practices.
Like having multiple locks on the door.
Precisely. It's all about creating those layers of defense to significantly reduce the risk of unauthorized access.
Okay, so it's clear this platform takes security very seriously, which is obviously table stakes these days.
Absolutely crucial.
But, in today's data world, no platform operates totally alone, does it?
Not effectively, no. Integration is key.
Which brings us to our next focus area, interoperability. How well does this platform work with other systems, and how does it embrace open standards?
Yeah, this is a really dynamic area right now. Being able to work smoothly with different data ecosystems is becoming just vital.
So what are the highlights there?
One of the key advancements mentioned is the platform's ability to directly read data stored in open source formats, specifically pointing out Delta tables.
Okay, Delta tables,
Yeah,
used a lot with Spark and Databricks, right?
exactly. For those who might not know, Delta Lake adds reliability and performance features on top of data lakes, and yeah, very commonly used with Spark and Databricks.
So being able to read that directly is a big deal. Avoids moving data.
It's a significant advantage, isn't it? If your organization is already heavily invested in those technologies, it avoids the hassle of constantly shifting data around or building complex integration pipelines.
Yeah, that sounds much simpler. And it gets even more interesting because the sources mention a new capability.
Mhm.
Something about converting Delta tables.
That's right. Easily converting Delta tables to the Iceberg format, another popular open table format, and then reading those Iceberg tables directly within the platform, and often with performance benefits too.
Interesting. So it's like translating your data into a more universally understood, maybe more efficient language for this platform.
That's a good way to put it. The process itself involves a few key steps mentioned in the sources.
Okay, what are they?
You set up what's called an external volume and an external stage. That basically tells the platform where your Delta files live.
Like pointing it to the right location.
Exactly. Then you create a Delta catalog integration. And finally, you create a new table within the platform that just points to that external Delta data.
So it's like creating a direct reference, a shortcut, to data that already exists somewhere else.
Precisely. It doesn't necessarily require moving the data itself, just understanding where it is and its format.
Got it. But the interoperability story doesn't stop there.
Yeah.
Like, let's talk about this Snowflake Open Catalog. What's the idea behind that?
Right. The Snowflake Open Catalog. It's powered by Apache Polaris, an open source project. It's designed to further boost this ability to work across different environments, especially with Iceberg tables.
So what does it actually do?
Think of it like a central directory, maybe a librarian, for your data tables, specifically your Iceberg tables in this context. It lets you connect to and manage these tables, making them accessible not just within this platform, but also to other compute engines like Databricks Spark.
So like one master index for important data, no matter where it physically sits.
Yeah, that's a really good analogy. It helps bridge those different systems.
Is it like a universal translator for data catalogs then, letting different systems understand each other's data structures?
Very apt analogy, yes. And the sources mention you have a couple of ways to set it up.
Options.
Yeah, you can manage it yourself, the self-hosted option, or use the cloud-hosted offering, which kind of simplifies the management side of things.
Okay. And how do you actually get these different systems talking through this open catalog? What's the process like?
It involves several steps, as outlined. Within the platform, you'd create a catalog connection. Then, in the open catalog service itself, you define your actual catalog. You also set up access controls using familiar role-based access control, RBAC, established trust relationships if your systems are in different cloud environments, for instance.
Okay, permissions and trust.
And finally, create the necessary catalog integrations and tables within the platform. It's sort of like setting up the proper credentials and handshakes for different systems to talk securely.
Sounds like a bit of digital diplomacy happening behind the scenes, ensuring everyone can share information nicely.
Exactly. And what's particularly powerful here is that you can then use the platform's catalog SDK within Databricks Spark to query data in these managed Iceberg tables.
Even if they're managed by the first platform.
Yes. And the sources even highlight this works across different cloud providers. So for example, if you have Databricks running on Azure, but your data lives in AWS S3,
The open catalog can bridge that.
it can help manage access to that data seamlessly. Yeah. That cross-cloud capability sounds incredibly useful for organizations with complex multi-cloud setups.
Definitely. And the sources mentioned something about data changes being reflected quickly, almost real time.
Yes, that's a key point. When you use these managed Iceberg tables via the open catalog, any changes made to the data within the platform, the one managing the table, are almost immediately visible within Databricks.
So no stale data issues.
It helps eliminate that problem, ensuring everyone's working with the most current information. Very important for consistency.
All right, so we've seen how this platform is becoming a better neighbor
Mm.
in the data ecosystem, playing well with others.
Mm.
Now, let's shift gears a bit. Let's focus on its ability to handle data in all its forms, not just neat tables and columns. We're talking unstructured stuff like documents and also that continuous flow of streaming data.
Yeah, this is where modern platforms really need to show their versatility, right? The sources definitely highlight this platform's ability to handle not just structured data, but also semi-structured formats. Think JSON, Avro, ORC, Parquet, XML.
The usual suspects for semi-structured data.
Right, and also completely unstructured data like PDF documents being a common example. It's about being able to work with whatever data you throw at it, regardless of format.
So it's really moving beyond just being a fancy place for spreadsheets in the cloud.
Way beyond.
How do you even get something like a PDF document into a data platform like this? And then what?
Well, the first step is typically loading this unstructured data into the platform's internal storage areas. They often call these stages.
Okay, like temporary landing zone.
Exactly. Once the data's there, the next challenge is, well, how do you get anything useful out of it? For PDFs, the sources detail a couple of approaches.
Like what?
One involves using user-defined functions, UDFs. These are basically custom bits of code you can write.
In familiar languages.
Yeah, like Java, using libraries like PDFbox, perhaps, or Python, using libraries like PyPDF2. These libraries give you the tools to programmatically pull the text content out of those PDF documents.
So you're essentially teaching the platform how to read these different file types.
You got it, giving it instructions. And the sources also highlight that the platform itself has a built-in function that actually uses AI to parse documents. That can simplify the process even further for common formats.
So maybe less custom coding needed sometimes.
Potentially, yes. And a key takeaway here is the platform's ability to scale its compute power automatically, on demand.
Why is that important for unstructured data?
Because processing large volumes of documents, especially complex ones, can be very computationally intensive. So having that elastic scaling is pretty crucial. You don't want processing to grind to a halt.
Right, makes sense. Now let's talk about the speed of data. The sources touch on needing real-time insights. How does this platform tackle that challenge?
Yeah, traditional data systems, often based on batch processing, struggle with the delays, the latency.
You get insights, but maybe hours or even a day later.
Exactly. This platform offers several options for handling streaming data, each kind of suited for different needs, how fast you need the data, how complex the streams are.
Okay, what are the options?
There's Snowpipe. It's often used for automatically loading data in small batches, micro batches, as new files land in storage. Think of it like a continuous trickle feed.
Okay, not quite real time, but much faster than big batches.
Right. Then there's the Kafka connector. This uses Snowpipe behind the scenes, but it's specifically designed to ingest data coming from Apache Kafka.
And Kafka is huge for real-time data streams, right?
Absolutely. It's a very popular choice for handling those continuous flows of data.
So Snowpipe, Kafka connector.
Yeah.
Any others?
Yes, there's a third option mentioned. Kafka with Snowpipe streaming. This is described as a more direct, lower latency way to stream data straight from Kafka topics into the platform's tables.
Lower latency. How does it achieve that?
It uses a new concept called a channel. The main difference seems to be that with Snowpipe streaming, the data doesn't necessarily have to land in that intermediate cloud storage stage first before being ingested and made available for querying.
So it bypasses a step, a more direct pipeline.
Seems that way, yeah. A more streamlined path for getting that real-time data in.
The sources mention performance benefits for both the Kafka connector and Snowpipe streaming compared to, say, basic Snowpipe for lots of small files. What kind of improvements?
Well, the Kafka connector can often get better throughput because it can smartly group rows of data together and use multiple data loading pipelines in parallel. It's just more efficient than processing tons of tiny individual files.
Okay, batching and parallelism.
Right. And Snowpipe streaming, because it's more direct, often shows even lower latency by skipping that intermediate staging step. It's all about getting that real-time data processed and ready for analysis faster.
And I guess the real power comes when you combine things. Having all this capability, historical data, batch, streaming in one place.
Absolutely. Being able to join that historical data we talked about earlier with these incoming real-time streams for immediate analysis for predictions, that's incredibly powerful.
Like having a live dashboard view right alongside your historical records, all queryable together.
Exactly. Imagine analyzing past sales trends while simultaneously watching a live feed of customer purchases to make instant inventory adjustments or maybe offer personalized promotions right now.
Yeah, that's the kind of agility businesses are looking for.
That's the goal this integration enables.
Okay, we've covered a lot of ground securing data, making it play well with others, handling all sorts of formats and speeds. Now, let's move to arguably one of the hottest topics, generative AI and machine learning integration.
Right. The AML piece. What are the sources saying here?
Well, what's this platform bringing to the AI landscape, based on what you read?
The sources highlight some really significant advancements, particularly mentioning developments around early 2025. A key thing is the availability of large language models, LLMs.
The tech behind things like ChatGPT.
Exactly. Models like DeepSeek R1 were mentioned, being available directly within the platform's AI service, which the sources refer to as Cortex.
Okay, Cortex, and this became generally available when?
Around March 2025, according to the material. Having these powerful AI models baked right into the platform, that's a major step.
That does sound like a potential game changer. What are the big advantages of having that direct integration?
There are several key benefits highlighted. First, it aims for ease of use, making these sophisticated models accessible even if you're not a deep AI expert.
Lowering the barrier to entry.
Right. And second, perhaps more importantly, these models operate within the platform's existing security boundary.
Ah, so you don't have to ship your data out.
Exactly. You can harness the power of these LLMs without sending your sensitive data to external third-party AI services. That addresses huge security and privacy concerns for many organizations.
Keeping your data inside your secure environment while still using state-of-the-art AI. Yeah, that has to be a major draw.
Huge advantage.
So how do you actually use these AI models within the platform? What are the different ways to interact?
The sources detail several methods. You can use SQL functions directly in your queries.
So AI analysis right within your SQL.
Yeah, which allows you to embed AI-powered analysis right into your existing data workflows. Pretty neat. There's also a Python API for more programmatic control.
For the developers and data scientists?
Right. A REST API for broader integration with other applications, and even a user-friendly model playground.
What's that?
It's basically an interface where you can experiment with different models side by side, try out prompts, see the results, all without writing any code.
Oh, that sounds incredibly useful for just trying things out and understanding what these models can do.
Definitely. It provides different levels of access to suit various technical skills and use cases.
Can you give us a concrete example from the sources? How might you use, say, DeepSeek R1 in practice?
Sure. The sources give an example using a simple SQL command. With just a basic SQL query, you can pass some text as a prompt to the model.
Like asking it a question or giving it an instruction?
Exactly. And you get a generated response back. This opens up all sorts of possibilities, generating creative text, summarizing long documents, extracting information, answering questions based on your data, all directly within your data environment.
So no need to export data to a separate AI tool or learn a whole new system. It's all integrated.
That's the idea. And the sources also mention Cortex's ability to directly analyze data within the platform.
Yes, an example highlighted was doing sentiment analysis on customer feedback.
Right. So Cortex can process that text data, maybe comments from surveys or reviews directly from your tables, and provide sentiment scores.
Letting you quickly see how customers are feeling about products or services.
Exactly, without needing complex data pipelines or external sentiment analysis tools. Much more streamlined.
And there was also mention of comparing different AI models.
Yes, the sources showcased a comparison. It was between DeepSeek R1 and another model, Claude 3.5, I believe.
What was the task?
It was a reasoning task providing travel recommendations for a specific city. The example showed how DeepSeek R1 apparently gave a more detailed, contextually relevant response, even kind of showing its thought process.
Ah, so you can evaluate which model works best for your specific need.
Exactly. That ability to compare outputs directly helps you choose the right AI tool for the job.
So it sounds like the platform isn't just giving you access to powerful AI models, but also making it easier to evaluate and select the best one for your task.
And doing it all within that secure, governed environment we talked about earlier.
And presumably with an eye on cost effectiveness too.
That's usually part of the pitch, yes. Making these cutting-edge LLM capabilities more accessible for a wider range of applications without the usual complexities and security headaches of using external AI services.
Wow. Okay, we have really covered a lot today. We've taken quite the deep dive into the recent advancements of this cloud data platform,
We certainly have.
from really fortifying your data with robust security and governance,
The foundation.
to breaking down data silos through better interoperability and embracing open standards like Iceberg,
Playing well with others.
handling that ever-increasing volume and variety of data unstructured, streaming,
All data types.
and finally, embedding those cutting-edge Gen AI and machine learning capabilities right inside the platform with services like Cortex.
Yeah, it's clear this platform is evolving far beyond just being a data warehouse, wouldn't you say?
Absolutely. It's aiming to be much more comprehensive.
And for you, the learner listening in, this represents a pretty significant shift. It's moving toward a more unified platform.
One place for diverse data and workloads.
Potentially, yes. Simplifying how you integrate and process data, providing that critical security and governance layer, and offering easier access to powerful AI and ML tools without maybe the traditional hurdles.
And as the sources suggest, there's this continuous stream of updates and new features being released all the time.
Which means the platform is constantly growing, constantly offering new possibilities, adding ongoing value.
Indeed. So, maybe a final thought for you, our listener, as you digest all this information.
Yeah, consider how these advancements could potentially, well, maybe revolutionize your own data workflows.
Where could you unlock new insights by leveraging these kinds of capabilities?
How might this drive innovation within your specific area of interest or your organization?
That's the next stage for your exploration, perhaps.
Some good food for thought there.
Excellent points. Thanks for joining me on this deep dive today.
My pleasure. Always interesting stuff.
And for everyone listening, until our next exploration, keep learning.